This is the University of Birmingham's video, Securing Technology Critical Metals for Britain, audio described version. The University of Birmingham wordmark and the Birmingham Energy Institute logo appear on the screen.
The Birmingham Centre for Strategic Elements and Critical Materials and the Critical Elements and Materials Network, also known as CREAM, have collaborated with Sir John Beddington to consider what policy measures will be key to securing technology metals for Britain.
A picture of the cover of the report, Securing Technology Critical Metals for Britain, ensuring the United Kingdom's supply of strategic elements and critical materials for a clean future, appears on the screen. On the report's cover, the website address for the report is listed as www.birmingham.ac.uk/CREAM Commission.
And ensuring the United Kingdom's supply of strategic elements and critical materials for a clean future.
A rotating globe appears on the screen. It stops and zooms in on the United Kingdom. A series of concentric circles focuses attention on the United Kingdom.
All around the world, nations are rapidly shifting to green, low-carbon technologies, transforming whole industries and sectors at a rapid pace.
The globe fades away and transitions to an aerial view of a landscape featuring a range of buildings and different technologies. The buildings and technologies change from dirty technologies to clean technologies like solar panels, wind turbines, electric cars and clean aviation. The video zooms in on an electric vehicle. Overlaid is a periodic table of elements.
These technologies are reliant on critical materials, a subset of which are technology metals. These technology metals are crucial for their performance and operation.
Certain elements of the periodic table are highlighted. These include helium, beryllium, magnesium, silicon, phosphorus, scandium, vanadium, chromium, cobalt, gallium, germanium, yttrium, niobium, ruthenium, rhodium, palladium, indium, antimony, hafnium, tantalum, tungsten, osmium, iridium, platinum, bismuth, lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Overlaid onto the periodic table are three boxes. One contains an electric car and the elements praseodymium, dysprosium, cobalt, neodymium and lithium are highlighted. The next box contains some offshore wind turbines. The elements neodymium, praseodymium and dysprosium are highlighted. The third box contains a jet engine. The elements rhenium, cobalt and tantalum are highlighted.
Both the primary resources and the processing capability for these materials are not uniformly distributed around the globe. However, they are of strategic economic importance to the UK, and some are at risk of short supply. Securing access to these technology metals will be critical for UK industry.
A world map fades into view. Certain countries are highlighted and elements appear over those countries. Over Russia, the elements platinum, palladium, rhodium, ruthenium, iridium and osmium appear. Over China, the elements cobalt, neodymium, dysprosium and samarium appear. Over Australia, the elements lithium, dysprosium, samarium and neodymium appear. Over the Democratic Republic of Congo, the element cobalt appears. Over South Africa, the elements palladium, platinum, rhodium, ruthenium, iridium and osmium appear. Over Brazil, niobium appears. and over Chile, lithium appears.
The coronavirus pandemic has highlighted the fragility of these global supply chains. Furthermore, our trading relationship with countries around the world is changing. The UK's departure from the EU will mean that it now has to consider its own independent strategy for critical materials and technology metals.
The world spins on a background of different flags. The stars of the European Union circle the world. One of these stars drops from the European Union flag onto a map of the United Kingdom. A map pushpin appears over the star. The pushpin turns into a light bulb with a series of rotating gears. The image of the periodic table with highlighted critical materials from earlier in the video appears again. The periodic table transitions to a boardroom scene with a committee sat around the table. On the screen of the boardroom is the cover of the report Securing Technology Critical Metals for Britain.
We have been working on policy recommendations that can help the UK harness the enormous economic opportunity that could come from securing technology metals for Britain.
A series of think bubbles appear from the heads of people around the table. One think bubble is the title of the report, another is a pile of accumulating money. A third think bubble contains a range of different elements.
But given the rapid pace of change and the global race to gain access to these materials, timely action is of the essence.
An image of the globe transitions into the clock face of Big Ben. The camera zooms away from the clock face to reveal the London skyline. A briefcase, 68% reduction in greenhouse gases by 2030.
There are several ways that materials criticality can be avoided. By reusing and recycling critical materials at the end of their lives, developing advanced recycling technologies to extract these materials from complex products, by diversifying supplies of critical materials, investing in new primary resources and the indigenous processing capacity to refine these materials.
A factory appears against a smoky, dirty skyline. A lorry arrives at the factory and drops off a consignment of what are presumed to be technology critical metals. Next to the factory, a recycling plant appears. A lorry full of waste appears outside the recycling plant and delivers it to the recycling plant. As the recycled products start to enter the factory, the fog clears from the background and the dirty image transitions into a cleaner image. A second technology metal processing plant appears on the other side of the factory. Lorries bearing nondescript flags of countries from around the world appear at the technology metal processing plant, signifying the diversification of supplies of materials to that plant.
By investing in science and innovation to develop technologies that substitute critical materials for those containing more earth-abundant elements.
The chimneys of the factory transition into 4 test tubes in a rack. They are surrounded by other laboratory equipment to signify science and innovation.
And by improved regulation around the consumption and use of these materials.
The 4 test tubes transition into the pillars of a porticoed building. The scales of justice appear to one side of that building, and money appears to the other side of the building.
With social and business model interventions to reduce the quantity of these materials our society uses.
The pillars of the porticoed building transition into 4 bars of a bar chart. The bars change size to show a decrease in the quantity of materials, and the colours of the bars change from red to red, orange, light green and dark green. This is meant to signify the reduction in the use of technology metals and the greening of processes.
The ideal scenario is a net zero circular economy that conserves resources, cuts emissions and increases recycling.
The bar graph images transition into a graphic. The graphic shows primary resources on the left-hand side entering a supply chain. The supply chain curls around to form a circle. The first element of the supply chain is exploration. This is followed by mining, processing, raw materials, design, production, use, reuse, collection, recycling and processing. The processing step then feeds back into the raw materials, signifying the circularity of the process. An arrow goes around the outside saying substitution of raw materials, and waste from that process exits to the environment. On the word cuts emissions, the arrows shrink. The circular diagram transitions into the shape of a gear.
All the while creating jobs, growth and prosperity for the United Kingdom.
The gear is surrounded by a series of interlocking gears which all turn. A series of icons appears on the gears. Those icons include shaking hands, a bag and pile of money, a porticoed building, a graph showing an upwards trajectory, a wind turbine, an electric vehicle, several people holding hands together, and someone standing in first place on a podium. These are all meant to signify success and prosperity. The gear transitions into a photo of Sir John Beddington, the chairman. This photo is flanked by two other photos. One is of Professor Alan Walton, Professor of Critical and Magnetic Materials and co-director of the Birmingham Centre for Strategic Elements and Critical Materials, and Dr. Paul Anderson, co-director of the Birmingham Centre for Strategic Elements and Critical Materials. Beneath them, the names of the other commissioners appear. Andy Abbott, Professor of Physical Chemistry, the University of Leicester; Andrew Bloodworth, the Science Director for Minerals and Waste at the British Geological Survey; Dave Udanijiweme, the Head of Technology Trends at the Advanced Propulsion Centre UK; Emma Schofield, Platinum Group Metals Research Fellow at Johnson Matthey; Francis Wall, Professor of Applied Mineralogy at the Camborne School of Mines, University of Exeter; Gavin Harper, that's myself, at the Birmingham Centre for Strategic Elements and Critical Materials; Neil Glover, Head of Materials Research at Rolls-Royce; Rob Chaddock, Strategic Development Manager at European Metal Recycling Limited; Robert Gross, Director at the UK Energy Research Centre; Robert Lee, Director of the Centre for Legal Education and Research at the University of Birmingham; Robin Grimes, Professor of Materials Physics at Imperial College; Rupert Lewis, the Chief Science Policy Officer at the Royal Society; and Vernon Gibson, Visiting Professor at Imperial College London. The Cream Network logo appears on the screen. Beneath it is the text to say the Cream Network is an initiative of the University of Birmingham and the University of Exeter and is funded by the UK Research and Innovation and the Engineering and Physical Sciences Research Council. The grant reference number for the CREAM network is EP/R020140/1. The logos of all of those organisations appear on the screen. Thank you for listening to the audio described version of the University of Birmingham's video for securing technology critical metals for Britain. This is the end of the video.